In this example, we want to determine the equation of the tangent line to the curve f of x is equal to e to the x divided by x at the point 1, e. And then when we're done, we want to verify our results on the graphing calculator. So first of all, remember, anytime you are writing the equation for any sort of a line, you need to figure out the slope of that line. So we need the slope and we need a point that is on the line. And luckily, we already have our point, so that's given to us. We just need to find the slope. And remember, the slope of a tangent line is found by computing the derivative. So we need to find the derivative of function f. Now, looking at function f, we can see that it is a quotient. It's e to the x divided by x. So because of that quotient, we're going to use the quotient rule. So the quotient rule says that we're going to take the function in the denominator, that's x. We're going to multiply it by the derivative of the function in the numerator. And the derivative of e to the x is e to the x. We sometimes call that low d high. So the little memory trick is you take the function in the denominator, the low, and multiply it by, we write d high. That just means the derivative of the function in the numerator, low d high, minus high, in other words, the function on top. And rather than writing h-i-g-h for high, yes, I do know how to spell. I just abbreviate it high. So high d low, which is the derivative of the function in the denominator. So let me keep going with what we have so far, and then we'll finish that. So far we've done low d high and then minus high. So that's e to the x, d low, the derivative of x is just 1. And then it's all divided by the low function squared. In other words, all divided by, in this case, x squared. So we say low d high minus high d low, all divided by low squared. And that's the little memory trick to help you remember the quotient rule. So here's our derivative, and I'm going to go ahead and simplify it. Although that's not really necessary in this problem, I like my students to get in the habit of simplifying. And so you can see that we have two terms in the numerator, and they both have an e to the x in common. So if we factor out an e to the x, we'll be left with the quantity x minus 1. So that's a nice factored form of our derivative, which represents the slope of the tangent line at any point on the curve f of x equals e to the x over x. Now, we want to know the slope specifically at the point given. So the slope of the tangent specifically at the point given is the derivative at 1, because 1 is the x value of the coordinate we were given. So we're basically finding f prime of 1. So that'll be e to the first power times 1 minus 1 all over 1 squared, which 1 minus 1 is 0, so we really end up with just 0. That's kind of interesting. So think about, what does that mean? Remember, this is the slope, and this is the slope of the tangent line. So therefore, if the tangent line has a slope of 0, you have to think, what type of line has a slope of 0? And a horizontal line does. So that means our slope is equal to 0, so the tangent line is horizontal. So we're really trying to write the equation for a horizontal line in this case. So if you kind of just think graphically for a second, I'm not even going to graph the function, I'm just going to think about the coordinate, the point that I was given, which was 1, we'll just call that e. So if I'm interested in writing the equation for the line that passes through this point, but it's a horizontal line, then the equation for that horizontal line would just be the horizontal line y equals e. Now, some of my students use point slope form quite a lot, so let me just show you. If you did want to use the point slope form of the line, y minus y sub 1 equals the slope m times x minus x sub 1. You could still do that here. The point that we would be using was the point given, which was 1, e. So that would be y minus e equals our slope, which was 0, times x minus 1. But that's just going to give us y minus e equals 0, which does indeed give us y equals e. So I suppose if you did do the point slope form, you would still arrive at this answer, but it's kind of a waste of time if you can just realize that the slope is 0, so the tangent line is horizontal, it's a lot faster to just think of it sort of graphically. So my answer here, the equation for that horizontal line, is the line y equals e. So now I want you to grab out your graphing calculator, and I'm actually going to do this in Desmos rather than using my graphing calculator because it's easier just to pull that up and show you all. So go ahead and graph the function. And again, our function was e to the x divided by x. So here's our function. And then if we think that the tangent line is going to have a slope of 0, and that line would be y equals e, then let's go ahead and graph the horizontal line y equals e here. And we basically just want to verify that indeed it is a horizontal line and that it is tangent to the curve. And hopefully you can see that it is certainly tangent. You can see that it's tangent right here. And that point of tangency certainly is, the x value is 1 right there. So you can see indeed we do have a tangent line to the curve when x equals 1, and that tangent line is horizontal, which means the slope is 0. So that just verifies that we did indeed do this correctly.